All right, so on this video, I'm going to do 3 problems involving quadratic functions that were sent to me. So I'm going to go to my computer, I'm going to share my screen and read the first problem, and you can follow along. Pause the video, write down the problem, write down the key bits of information. So I'm sharing my screen, here we go. All right, so that is right here. Share. Okay, so this says the college of a campus has plans to construct a rectangular parking lot on land bordered by one side of a highway. There are 640 feet of fencing available to fence the other 3 sides. Let X represent each of the parallel sides of fencing. And we are going to do 5 things right now for this problem. The first thing is we're going to express the remaining side to be fenced in terms of X. We're going to look at what the restrictions are on X. We're going to determine a function, which we will call A, that expresses the area in terms of X. We're going to determine the value of X that will give an area of 40,000 square feet. And then finally, what dimensions give the maximum area and what will that area be? Okay, here we go. Hopefully it works this time. Let's stop sharing. And let's go back. All right, things are working better than they did last time. So first part of the problem, the A part, says, express the remaining side to be fenced in terms of X. So here's the situation that this problem described. There is a road, okay? Okay, that marker doesn't work. Technology issues, I guess. Let's try a different color. There is a road, okay? This is the road. And what this college wants to do is they want to create a parking area, parking enclosure. They are going to fence in the other 3 sides. And so what the problem established, if you wrote it down or wrote down the key information, what the problem established is to let X represent the parallel sides. So here's X. So the first part to the problem says, okay, what is an expression in terms of X for this other side? Well, we're told in the problem that the college has 700 feet of fencing, must just be laying around behind a garage or something like that. So that means when I add up these 3 sides, X, the unknown side, and X, that should add up to 700. Well, I explained this on a different video, but if we put numbers on, let's say X is 100 and 100. We're just making up numbers. That means 100 plus 100 is 200. So what's left for this side? Well, that would be the 700 minus the 200. So that would be 500 left for this side. But in this particular problem, we don't know what the value of X is. So if I go out X feet here and I go out X feet here, what that means is between these 2 sides, I've used 2X. And so what remains for the third side is the 700 feet of fencing I have when I start, minus what I've already used, which is 2X. So that is the answer to the A part to the problem. Okay, the B part to the problem. The B part to the problem says, what are the restrictions on X? Well, we have to answer this question because it is a quote-unquote real-world situation, even though it is a simple situation. Remember, simple doesn't mean easy. It's a simple situation, but it still is technically real-world, and we have to see what's happening. So if I'm building a fence, well, we can't have negative fencing. So what that means is this side right here has to be bigger than 0. Okay? That means it has to have some dimension, 1 foot, 2 foot, 3 foot, 9 feet, whatever. This side right here, 700 minus 2X, that also has to be bigger than 0 because that side can't be a negative value. And so I'm going to solve this. I'm going to subtract 700 from both sides, and I get negative 2X is greater than negative 700. And then from there, I'm going to divide both sides by negative 2. And remember, when I divide by a negative, I have to flip the sign. So that means X has to be less than 350. So that gives me the constraints, the restrictions on X. X has to be bigger than 0. And at the same time, X has to be less than 350 feet. So that is the B part. What are the restrictions on X? If you are still writing things down, remember this is a video, you can pause. I'm just moving through so that the video is not too long when I post it on YouTube. The third part says, what's the function a that expresses the area in terms of x? Okay, great question. Well, this is just a rectangle. I don't know if you remember your high school or middle school geometry. You can always Google this. What's the area of a rectangle? The area of a rectangle is just the length times the width. The two dimensions of the rectangle. You multiply those two things together. So I'm going to take x, I'm going to multiply it by 700 minus 2x, and there's my function for the area. I'm going to distribute. This x right here is the dimension. I'm going to erase that because that looks confusing. I'll put it inside right here. So I've got x times 700 minus 2x. That's 700x minus 2x squared. And just because in a moment we are going to have to do things with this, I'm going to write it in descending order. So I've got minus 2x squared plus 700x. That is my area function, a of x. That's the third part to the problem. The fourth and fifth parts to the problem are going to ask us to do things with this. So what I'm going to do is I'm going to erase, I'm going to transcribe my area function up here so I have it to work with. So a of x is equal to negative 2x squared plus 700x. That is the area in terms of whatever value I choose to build out from the road on this particular problem. So the fourth part to the problem, D, says determine the value of x that, determine the value of x that will give an area of 40,000 square feet. I'm not going to work this part all the way through. I'm going to show you how to set it up. What this is saying is, okay, I know for whatever reason, maybe it's the amount of concrete I can afford or the amount of pavement I can afford. I know that all I can afford is 40,000 square feet. So what I want to know is what value of x produces 40,000. And so what I have here is I have a quadratic function. I'm going to get everything on the same side, so it's equal to 0. Anytime we solve a quadratic equation, it has to be equal to 0. So I'm going to add the 2x squared over here. I'm going to subtract the 700x. I've got plus 40,000 equals 0. Now from here, this is just a quadratic equation. I would use the quadratic formula, use your calculator, and come up with the value of x that is going to solve that equation. So I'm just going to write here, you're going to solve using your good buddy, the quadratic formula. One more part to this problem. The last part to this problem says, okay, we have figured out the value of x for a specific area that we want, but what if we have no constraints on our money and we just want to build the biggest parking lot possible? So the last one is we want to maximize this. Now, we know it's a maximization problem because this parabola is pointing downward, okay? It's pointing down, so that means the vertex is at the top. It is a maximum. So when you are asked to maximize or minimize a quadratic function, you are finding the vertex. Okay, so what we are going to do for the last part is we're going to use the vertex formula. So remember the vertex formula, the x-coordinate of the vertex is negative b over 2a. And so the value of b here is 700, so that's negative 700 in the top. Where'd that negative come from? From the formula. 2 times a is 2 times the value of a, which is negative 2. So that's negative 700 over negative 4. And negative 700 over negative 4, let me go ahead and make sure I'm doing this right. On a video, you only get one chance. And that is going to be 175. So what that means is the maximum area occurs when this side right here is 175 feet. To find the other dimension, I'm going to leave the last couple bits of this to you. To find the other dimension, that's the width. To find the length, you're going to plug 175 in right here. And then you're going to figure out what that value is going to be. It looks like it's going to be 350. And then finally, to find the maximum area, you're going to take your area function right there, and you're going to plug in 175. And so that's negative 2 times 175 squared plus 700 times 175. And once you do that, that gives you the area that is maximum under these constraints. Okay, that's the first problem that was sent to me. I'm going to share my screen again, and I'm going to read to you the second problem that was sent for me to discuss. So here we go. I'm sharing my screen. You can see my nice bald head on the video. Ignore that. So here we go. So here's my screen again. It says this: a piece of cardboard is 2 times as long as it is wide. It is to be made into a box with an open top by cutting 4-inch squares from each corner and folding up the sides. Let X represent the width of the original piece of cardboard. Answer the following questions, and there are 4. We are going to represent the length of the original piece of cardboard in terms of X. We're going to give the restrictions on X, and then what are the dimensions of the bottom of the base of the box. We're going to determine a volume function, and then what value of X produces a box with a value of 100 inches cubed. Okay. So I'm back. If you needed to write down more of that, go ahead and rewind the video. It's a YouTube video. You know how to use YouTube, and go ahead and stop it and write down the key bits of information. So here's what we've got. We're told in the problem that we've got a piece of cardboard. We don't know much about the cardboard piece, but what we do know is that the length is 2 times the width of the cardboard box. So what the problem instructs us is to let the width be X. And now we're going to go through the 4 parts to the problem. The first part to the problem says, what's the length of the box? Well, if the problem says the length is 2 times the width, and the width is X, what is this value going to be? Well, twice means it's going to be 2X. So that's the answer to the A part. The A part is 2 times X. The B part says, okay, now that we're going to cut off 4-inch corners. So what it says is we're going to cut off 4-inch corner. I'm just going to call that 4. Okay, so 4, and then we're going to cut off 4 here. Okay, that's 4. We're going to cut off 4 here. That's 4. And then 4. That's 4. Excuse me. What that says is, okay, I've cut off, use some scissors on the cardboard. I've cut off these 4-inch things. And then what I'm going to do is I'm going to fold up these flaps to form a box. So the second part to the problem is, what's the restriction on X? Well, here's the thing. If I cut off 4 inches here, and I cut off 4 inches here, how big does X have to be so that there's any cardboard left? Well, X would have to be, so here's the B part to the problem, X would have to be bigger than 8 inches, right? Because I've got 4 inches here and 4 inches here. If X is like, if this whole side from here to here is like 5 inches, well, I don't have enough cardboard to cut off 4 on this side and 4 on that side. Okay, so X has to be bigger than 8 inches. All right, the next part to the problem says, I'm sorry, we didn't finish the B part to the problem. So X has to be bigger than 8 inches. Then we're told to determine what are the dimensions if I do fold up. So I'm going to draw some red dotted lines. I'm going to fold up these 4 sides to form a box. So what are the dimensions of the sides? Well, if this side right here is X, then this little red side right here is going to be X minus 4 on this side and 4 on this side. That's minus 8. And if this side was 2X, it was twice that, then what that means is this red side is going to be 2X minus 4 on this side and 4 on this side, minus 8. So those are the dimensions of the base of the box. Now I understand for the person who sent this to me, I understand that this problem was written a little weird and it was a little bit, I think it was a little bit confusing to get that information. So I understand why you're asking this question. The C part, the third part to the problem says, what is a volume function in terms of X? Well, again, a little bit of middle school geometry. If you don't remember that, you can just Google how do I find the volume of a box? And you'll be told that the volume of a box is the length times the width times the height. Okay, Well, the volume is then going to be the length of the box, 2x minus 8. That's the bottom. The width of the box, that's x minus 8. Times the height of the box. And the height of the box, when I flip this side up, the height of the box becomes 4. Now, at this point, you just multiply that together. This is a little bit of introductory algebra for you. What we got is 2x squared, and then minus 16x minus 8x is minus 24x, plus 64 times 4. Then I distribute, and I get that my volume function is 8x squared minus, that is going to be 96x plus, and then 4 times that is 256. That's your volume function. So no matter how big this cardboard piece is, that's the volume. Where would you use something like this? Again, this is a simplified example, but there are people that actually design boxes for the things that we buy in the grocery store or when we order stuff on Amazon. And so this is how they would determine the volume depending on the original dimensions of the box. The last part to this problem, it's very similar to the previous problem. It says, okay, what value of x would produce a box that has a 100 cubic inch volume? And I'm just going to set this up. What that means is I'm going to let the volume be 100 because that's what I'm interested in. 8x squared minus 96x plus 256. You'll subtract 100 from both sides, and again, use the quadratic formula to determine the dimensions. Use your calculator, give an approximation, follow any instructions in My Math Lab to how many decimal places and things like that, and all will go well with you. All right, the last problem I was sent is a little bit simpler. Again, let me share my screen. Again, there's my bald head. So here goes. I'm flipping this down. This last one says a baseball dropped from a stadium seat that is 110 feet above the ground. Its height S. So S represents the height. I don't know why they didn't use H, but they used S. It's okay. The height in feet is, after t seconds, is given by the function S of t. The height at t seconds is 110 minus 16t squared, a basic physics equation. Estimate how long it takes the baseball to hit the ground. Okay, so this is our last problem. Stand up. So we're told that the height S at any moment t is equal to 110. I have different numbers on my page. 110 minus 16t squared. And we want to know how long, what's the time, that's what how long it means. That's what how long means. The time it takes to hit the ground. Okay, well, if S represents the height, the ground is what height? Well, the ground would be a height, an S of 0. Okay, that's where everything started. And so this problem just means take 0 equals 110 minus 16t squared. You can use the quadratic formula right here. What I'm going to do is I'm going to add the 16t squared, divide by 16. And then at that point, the rest of this, since I'm out of room on my board, I'm going to leave to you. You're going to take the square root of this. Again, we're just getting in an approximation and use your calculator and come up with the answer. So those are 3 introductory application problems for quadratics. I hope this has been helpful. Have a great day.